So the next couple of lessons that we are going to look at are going to cover graphing polynomial functions, or I'm sorry, rational functions. We've already done polynomials. So just a quick reminder, rational functions are basically when you're dividing two different polynomials. Okay, so P of x and Q of x are polynomials, no common factors, okay, and the degree of the denominator has to be at least 1. So there has to be at least some variable in the denominator. Okay, we're going to come back to this common factor thing and how something like that would impact a graph. So that will be something that we kind of address. But we are going to have basically 3 different times that we're going to talk about graphing rational functions, because these ones can be a little bit complicated. So you're going to see today we're going to look at just simple ones. The next class, we're going to talk about not so simple ones. Okay, and then after that, we're actually going to look at ones where they're so complicated that we have to use a calculator to help us out. Okay, so today we're starting with the simple ones. You should be able to graph these by hand, kind of using what you know about transformations. Okay, so let's take a look at this. Okay, so when we look at these, whenever you're graphing a exponential function, not an exponential, I'm sorry, rational. I keep forgetting that word today. Okay, these ones look funny. Okay, so these are going to be kind of a funny looking graph compared to what we usually look at. So really quick, just to give you an idea of what the graph of 1 over x would look like. So y equals 1 over x. Okay, so the general idea of what this is going to look like is we're going to have some asymptotes. Okay, your asymptotes for just a 1 over x graph are going to be the x-axis and the y-axis. And the graph is kind of like these two branchy things, right? So it kind of comes like this in this section where it's approaching both of those asymptotes, and here in this section where it's approaching those asymptotes. Okay, so that's sort of what this is going to look like. Now, in terms of a table of values for this guy, the table of values is a little bit weird, okay? Because if you plug in, say, 1 into this graph for x, then you're going to get out 1 for y. If you plug in 2, you're going to get out a half. If you plug in 3, you're going to get out a third. Okay? 0, can't plug that in. That's why there's an asymptote there, right? You can't divide by 0. -1, you're going to get out -1. -2, you get out negative a half. Negative a third, right? So you get kind of this idea where it's approaching these asymptotes in these kind of 2 different chunks. Okay? But it's kind of like this isn't the kind of table of values that we're going to use as our general go-to, okay? So we're going to kind of use a little bit of a cheat. Instead of using this as a modified table of values, we're going to kind of approach this in a different way of thinking, okay? So let's talk about this guy. So what's the difference between these 2 functions? Well, just like always, our good friend, right? This is multiplied by 6. This is a vertical stretch in terms of 6. So if we were going to use this lovely table of values, okay, what we would do is we would just multiply all of these y values by 6, okay? But if you sort of think to yourself, for this one, it wouldn't be that bad because we're taking a half and a third of 6. But think about like if it was a 7 on the top or a 5, it'd be sort of annoying. Okay, so here's how we're going to approach this instead. Instead of using this and using that as a modified table of values, we're going to make a lovely little xy table for this particular one. Okay, where the number at the top is going to be the product of x and y. Okay, because think about it. If I multiplied this equation, I could rewrite this equation, multiply both sides by x, and you'd get xy equals 6, right? So the product of these 2 numbers is 6. So I'm going to come up with pairs of numbers that multiply to 6. So like 1 and 6, 2 and 3, 3 and 2, 6 and 1. I'm just picking the easy ones. And on the negative side, -1 and -6, -2, -3, -3, -2, -6, -1. Okay, so that is my table of values. And then when I go to plot these points, here's -6, -1, -3, -2, -2, -3, -1, -6. Okay, we said before these are asymptotes, right? Because there's no way you could plug in 0 for either x or y into this equation and have it work, right? So that's why we're going to end up with asymptotes there. So there's that part of the graph. And then over here, here's 1, 6, 2, 3, 3, 2, 6, 1. Same kind of deal happening. Okay. So whenever you're graphing these kinds of functions, right, you're always going to have two branches, if you will, sometimes more, but usually two. Okay. And you're going to have two asymptotes. Okay. And that will be true for the level 1 and level 2 graphs that we do. The calculator assisted ones, that's when things are going to get a little bit fun. Okay, so then let's take a look at this next one. So for this guy, you notice that we have a change to our x value. Well, just like always, this is going to be a left-right shift backwards of what you'd think it would be. So normally you'd think it would go to the left, but it doesn't. This is going to take you to the right too. So that hasn't changed. And the 6 on the top is telling you that's what the product should be for your table of values. So I'm going to go ahead and shift to the right too. So I'm going to move my asymptote over too. And this asymptote would just stay put. And then from there, we can use the same table of values. So things that multiply together to get you 6. So starting from where these two cross each other, we're doing our modified table of values, but using this guy, this product of 6. Okay, so starting from here, I'd go over 6. Right? And down 1, here's -3, -2, -2, -3, -6, -1, or -1, -6, excuse me. So there's that part. Here's 1, 6, 2, 3, 3, 2, 6, 1, and there we go. There's my graph. Lovely. Okay. This guy over here. So this one, we're still going to have a product of 6. So 6 is still going to be my product. Okay. And this guy, adding 3 at the end, that's going to shift you up 3, just like always. So I'm shifting up 3. My horizontal asymptote, or my vertical asymptote, excuse me, didn't shift because we didn't shift horizontally at all. And again, we want our product to be 6. So I'm looking for numbers that multiply to 6. So there's 1, 6, 2, 3, 3, 2, 6, 1. And same thing over here. So pairs of numbers that multiply to give you 6. Okay. So that's not too big of a deal. This guy, so this one we got 2 shifts. This one's going to take us to the right 2 and down 3. And again, our product is 6. They're not always going to have a product of 6. These particular ones do. Okay. If you had a different product, you would probably have fewer points. Okay. 6 has a lot of nice pairs of numbers that multiply it. But if you had like 4 as your product, you're going to have 1, 4, 2, 2, and 4, 1, right? So you'll have fewer points there. If you had like 3 as your product, you're going to have 1, 3, and 3, 1. Okay, so depending on what your product is, you may have a lot of points that you can graph, or you may have very few. Just plot as many as makes sense for that particular product. All right, so here's right 2. Okay, here's down 3. All right, and from our modified origin, I'm going to do the same thing. So here's 1, 6, right? Here's 2, 3, 3, 2, 6, 1. Approaching my asymptotes. Here's -6, -1, -3, -2, -2, -3, and -1, -6. There we go. All right, and then our last but certainly not least one. So this one, the big piece that we're adding in is this vertical flip. So this guy, this is going to take me to the left 1. This will take me down 3. My product. So now what I'm going to kind of do is I'm going to think about the negative being with the 6. Okay, so I'm thinking of this as my product being -6. Okay, so instead of positive 6, negative 6. So what is that going to change? Okay, well, it's going to change just a little bit. Okay, so when I go and do this, here's my left 1, down 3. Okay, so now I want things that multiply to negative 6. So when I go over 1, 1 times negative 6 would be negative 6. So I'm going to go over 1 and down 6. Right? I'll go over 2 and down 3 because 2 times negative 3. Right? Over 3 times negative 2. Over 6 times negative 1. Okay. Or alternatively, you can think about it as doing a vertical flip. Normally, I'd go over 6 and down 1, right? Well, now I'm going to go over 6 and up 1. Normally, I go over 3 and down 2. Well, now I'm going to go over 3 and up 2, right? And then over 2 and up 3, over 1 and up 6. Okay, so you can think about it either way, either as making your product be that negative number, or you can think about it as just flipping like we normally would. Okay, great. So we've kind of looked at these. All right. Now, the other thing that you're going to need to be able to do is I'm going to ask you to write the equations for the asymptotes of these graphs. Okay. So let's go back through these really quick and write the equations of our asymptotes. So for this particular one, right, our horizontal asymptote and our vertical asymptotes are both just at 0. Okay. So my horizontal asymptote is the equation x equals, y equals 0, right? Because this is the horizontal one, sorry, right? And what do all those points have in common? The y coordinate is 0. So y equals 0. Vertical asymptote, this guy, what do all those points have in common? Well, their y coordinates change, but their x coordinate is always 0. So there's the equation for that line. Okay, this one, my horizontal asymptote, right? This guy, what do those all have in common? Well, they have an x coordinate of 0. And my vertical asymptote, what do those all have in common? Well, those have an x coordinate of 2. I screwed this up. These guys do not have x equals 0 in common. They have y equals 0 in common. I usually do the vertical ones first and then the horizontal ones, and I accidentally did them backwards, and it's totally throwing me off. All right, this guy, horizontal. I'm going to be more careful this time. That's this guy. What do they all have in common? Their height. Okay, height is your y coordinate. So y equals 3 is my horizontal asymptote. Vertical asymptote, that's this guy. What do they all have in common? Well, they all have their sideways component in common. So x equals 0. All right, this guy over here. All right, horizontal asymptote. This guy, what do they have in common? Their height. They all have a height of -3. So y equals -3. This guy, what do they have in common? Well, their sideways coordinate is in common. So x, they all have a x coordinate of 2. That's my vertical asymptote. Okay, this guy here, horizontal asymptote. This guy, what do they have in common? Their height. So their y coordinate is always -3. Okay, and then their vertical asymptote, what do they have in common? Well, their x coordinate is always -1. Okay, so from that, if you kind of have been paying attention, you can see that you could just look at the equation to pull out these asymptotes, right? My horizontal asymptote is tied into my vertical shift, right? Horizontal asymptote, vertical shift. Horizontal asymptote, vertical shift. Horizontal asymptote, vertical shift. There isn't one. Okay, and then my vertical asymptote is tied into my horizontal shift, right? So there's that guy. This had a shift of 0. This guy shifted 2, right? And then this guy shifted 1. So when you look at the generic form of what these look like, if you want to pull out your horizontal asymptote, okay, your horizontal asymptote is just always y equals whatever this k value is. Your vertical asymptote is always x equals whatever this h value is, right, with the understanding that the minus is built in, which is why it ends up being backwards of what it looks like in the equation, right? All right, and then finally, your product is always that a value. Okay, so that's kind of what the generic format of this equation looks like and what you pull from it. So that is step one of how you graph simple rational functions where you just have a product that you need to deal with and some shifts.